Hello, my fabulous fourth graders. I wanted to review adding and subtracting mixed numbers with you guys, particularly those of you who were not able to come to our math mini lesson on Tuesday. This is what we were working on, and it was something that I was hearing back from many of you that you were having trouble with. So I wanted you to have this as a resource on Google Classroom to go back and reference if you needed it, whether you were at our mini lesson or not. So we're going to start by working on adding mixed numbers. So when you add mixed numbers, for example, you have this problem 4 and 5/8 plus 3 and 1/2, your first step is always going to be to put the whole numbers to the side. I like to say that those whole numbers are in timeout. I literally put them in a little box to the side. And then you're going to rewrite the problem with fractions only. That allows you to think about one small chunk at a time and not worry about the fraction and the mixed number as a whole. You can just think about one little part. So we're literally going to put them in a timeout. Now, their timeout's not a punishment. I like to think of it as a delightful spa day for the whole numbers. We're just putting them to the side. We're going to deal with them later. You do want to rewrite your fractions, and that's going to give us 5/8 plus 1/2. So now that we have our fractions written out as an equation, we need our fractions to have the same denominator before we're able to add them. So our second step is going to be to find the LCM of both of our denominators, and that LCM is going to become the new common denominator for our fractions. So there's a reason why we find that LCM. That's going to tell us what new denominator our fractions will have. So I've written out the first 6 multiples of both of our denominators, and as I look, I can see that 8 is our least common denominator. At this point, it's actually our only common denominator. However, if we had continued to find multiples of 2, we would find that we have several more common denominators. But for the first 6, 8 is the only one we see, and that's the only one we need. Now that we have our LCM, we're ready to go ahead and convert the fractions so that they have a common denominator. And remember, we found the LCM so that we would know what denominator our new fractions should have. So the first thing you're going to do is write out your original fraction, and I like to go one at a time, so I have 5/8 first, but I already have a denominator of 8, so there isn't any need for me to convert it. It's already ready, it's good to go. 1/2, however, does need to be changed, so I rewrite that original fraction. I'm going to write the new denominator right next to it, and then, because I have my two denominators that I can use to compare, I'm going to ask myself how many times will 2 go into 8? Well, 2 will go into 8 4 times. So I can apply that little rule to my numerator. Whatever I did to the denominator, I must do to the numerator. So I'm going to multiply 1 by 4 as well. 1 times 4 gives me a new numerator of 4. And now I have my converted fraction for 1/2. Now that you've converted your fractions, you're ready to go ahead and add them together. And again, the purpose of converting them was so that you could add at all. Now you have two fractions with the same denominator, which allows you to add. So we have 5/8 plus 4/8. 5 plus 4 gives us 9, and our denominator stays the same, so we have 9/8. This particular problem has resulted in an improper fraction, and we don't have any issues with an improper fraction, but we do want to make sure that we convert them back to a mixed number before we move on. So our next step is going to take that improper fraction and convert it to a mixed number. In order to do that, we're going to decompose the fraction and we're going to pull the whole number out of it. So if I'm taking one whole away from 9/8, I'm really taking 8/8 away. The reason why I've used the fraction 8/8 is because if my numerator and denominator are the same, I know I have 1. I chose to use 8 as my denominator because I'm taking it away from 9/8. In order to take anything away or add to it, it has to have the same denominator. So I'm going to take 8/8 out of 9/8, and when I take that 8/8 or one whole away, I'm left with 1/8. Now I haven't gotten rid of the 8/8, I've just pulled it out so that I could make it into a 1 whole that I've put in front of my proper fraction 1/8. So our mixed number is going to be 1 and 1/8. The next thing I need to do is go ahead and break those whole numbers out of timeout and add them together. They've done their job, they've hung out to the side so that we could add the fractions, and now we're ready for them. So we're going to add 4 plus 3, and that'll give us 7. And then our final step is just to add our whole number to our mixed number. We're going to put it back together. So that gives us 7 plus 1 and 1/8. 7 plus 1, of course, is 8, and our 1/8 stays with it, so 8 and 1/8 is our final answer. We're finally done! 7 steps, but we made it. We're going to go through roughly the same steps for subtracting mixed numbers, but there are going to be a few little differences. So we have the problem 5 and 1/2 minus 3 and 4/5, and our first step is exactly the same. We want to simplify this problem by putting the whole numbers to the side and time out and rewriting the problem with just our fractions only. That's going to give us the problem 1/2 minus 4/5. Now, we don't have the same denominator, again, same issue, so we're going to have to convert the fractions to have the same denominator. In order to do that, we need to find the LCM. The LCM of 2 and 5 is going to be 10. Now that we have that LCM of 10, we can go ahead and convert our fractions to have a common denominator. In this case, neither of my fractions have a denominator of 10, so I'm going to have to convert them both. I'll start with 1/2, and then I'm going to write the new denominator next door. I know my new denominator is 10 because that's my LCM. Now, 2 will go into 10 5 times, so I'm going to apply that to my numerator as well. 1 times 5 is going to give me 5. So my converted fraction for 1/2 is 5/10. I now need to do the same for 4/5. So I rewrite my original fraction, I put my new denominator to the side, and then I ask how many times will 5 go into 10. It'll go in 2 times. Whatever I do to the bottom, I apply that rule to the top. 4 times 2 is going to give me 8. Now I have 2 fractions with the same denominator, and I'm good to go. I can go ahead and subtract them. However, in this case, I have 5/10 minus 8/10, and 5/10 is smaller than 8/10, so if I only have 5/10, I can't possibly take 8 away. That's like saying that I have 5 pieces of candy on my desk, and you're going to go take 8 of them. How can you take 8? I only have 5. In this case, we're going to have to borrow from our whole number. So we're going to take from the 5, and the reason why we took 1 from the 5 is because the 5 is the whole number that goes with the fraction 5/10. It goes with originally 1/2, but 5/10 is our converted version. So we're going to take from the 5 because that's the whole number that goes with our fraction. When we take that 1, we're then going to add it to our 5/10, but it has to be in fraction form for us to do that. I've chosen tenths because in order to add to 5/10, I have to have a denominator of 10. So 10/10 is representing my 1, and I'm going to go ahead and add that to 5/10. When I do that, I'm going to get 15/10, and now that is large enough that I can take away 8/10. 15/10 minus 8/10 will give me 7/10. Now I've taken care of my fractions, so it's time to break my whole numbers out of timeout and go ahead and subtract. That'll leave me with 4 minus 3, which gives me a difference of 1. My final step, and I'm almost done, is just to take the whole number and the fraction and put them back together, just like we did when we added. So 1 with my 7/10 gives me a mixed number of 1 and 7/10, and that is your final answer. We are finally done. All right, as always, guys, if you have any questions, anything you need help with, please reach out. I'm here to help you. I will Zoom with you. I will make you another video. We can do problems together, whatever you need. Reach out. I'm here to help. All right, good luck, guys.